A filter is an electronic circuit or algorithm designed to modify the frequency content of a signal. The primary purpose of filters is to selectively pass or attenuate specific frequencies in a signal, according to desired criteria. Filters help eliminate unwanted noise, enhance desired signal components, shape the frequency response, and extract specific information from signals. Filters play a crucial role in various fields of signal processing, including audio processing, telecommunications, image processing, and control systems. In audio processing, filters are used to equalize sound, separate different frequency bands, remove interference, and ensure efficient signal transmission. In image processing, filters enhance image quality, reduce noise, and perform image transformations. In control systems, filters are utilized to eliminate noise, suppress disturbances, and shape the frequency response of control signals. Filters can be implemented using analog circuit components such as resistors, capacitors, and inductors, or using digital signal processing algorithms and techniques. Analog filters and digital filters each have their own applications and characteristics. Filters can also be classified based on their frequency response characteristics. Low-pass filters allow frequencies below a certain cutoff frequency to pass while attenuating higher frequencies. High-pass filters allow frequencies above a certain cutoff frequency to pass while attenuating lower frequencies. Band-pass filters allow a specific range of frequencies to pass while attenuating frequencies outside the desired range. Band-stop filters attenuate a specific range of frequencies while allowing frequencies outside that range to pass. Other classifications include active filters, which utilize active components such as operational amplifiers, and passive filters, which utilize passive components such as resistors, capacitors, and inductors. The frequency response of a filter describes how it behaves across different frequencies. The passband is the range of frequencies where the filter allows signals to pass through with minimal attenuation. The stopband is the range of frequencies where the filter attenuates or blocks signals. The cutoff frequency is the boundary frequency that separates the passband and stopband. The filter order indicates the complexity of the filter and determines its steepness in the transition between the passband and stopband. Higher filter orders result in steeper roll-off rates, achieving greater attenuation in the stopband. Filter orders are typically determined by the number of reactive elements, capacitors or inductors, or stages in the filter design. Ripple refers to the small variations in gain or attenuation within the passband or stopband of a filter. In filters with ripple, the gain or attenuation deviates slightly from the ideal response. Attenuation specifies the level of signal reduction or suppression that a filter provides in the stopband. Filters are designed to have high attenuation in the stopband to minimize unwanted signal components. Phase response describes how the filter affects the phase shift of different frequency components in the input signal. Group delay is a measure of the average time delay experienced by different frequency components in the filter. Flat or linear phase response across the passband is desired to maintain signal integrity and prevent distortion in time-dependent signals. Equalization filters are used to adjust the frequency response of audio signals, allowing for boosting or attenuating specific frequency ranges. Crossover filters divide an audio signal into different frequency bands for specific speakers or drivers, such as tweeters, midrange, and woofers in a multi-way speaker system. These filters help optimize the sound reproduction and achieve balanced audio output across different frequency ranges. In communication systems, modulation filters are used to shape the spectrum of the modulated signal, ensuring efficient use of the available bandwidth. Demodulation filters extract the baseband signal from the modulated carrier in the receiver, allowing for signal detection and decoding. These filters play a crucial role in achieving reliable and accurate transmission of information in various communication systems, such as wireless, wired, and digital communication. Smoothing filters, also known as low-pass filters, are used in image and video processing to reduce noise and blur unwanted details. Edge detection filters, such as high-pass filters, are employed to enhance edges and boundaries between different regions in images and videos, enabling tasks like object detection and image segmentation. These filters assist in improving image quality, enhancing visual features, and enabling various computer vision applications, including image recognition, object tracking, and video analysis. Anti-aliasing filters are used in analog to digital conversion systems to prevent aliasing artifacts by attenuating frequencies above the Nyquist frequency. Anti-imaging filters are used in digital to analog conversion systems to remove or attenuate image frequencies that can cause distortion or artifacts during signal reconstruction. These filters ensure accurate and faithful representation of analog signals in digital systems, maintaining signal fidelity and preventing unwanted artifacts in measurement and instrumentation applications. Thanks for watching.